This video is a preview of the MathGalaxy pre-algebra fun tutorial, where we'll be looking at scientific and metric notation and operations. In order to review scientific and metric notation, you need to be familiar with negative numbers, multiplying and dividing by tens, and exponents. So if you're not familiar with those topics, you should review them in our other videos first. Exponents are just a shorthand way of writing repeated multiplication of numbers. And in scientific and metric notation, that means powers of 10. So 1,000 can be written as 10 cubed, 3 signifying 10 multiplied 3 times. And scientific and metric notation uses powers to represent very large or very small numbers in a shorthand form. Instead of writing a number with a whole lot of zeros, they use powers of 10. Scientific and metric notation breaks a number down into two components, a decimal part called the mantissa and powers of 10. For example, 5,000 can be represented as 5 times 1,000 or 5 times 10 cubed. And in scientific notation, you want to have one non-zero digit to the left of the decimal point. So remember, if there's no decimal point, it's understood to be the right of the number. So if you want to convert a large number to scientific notation, you want to, in this case, get the decimal point to be 2.5. So to do that, you have to reduce the mantissa by 1, 2, 3, 4 powers of 10. But that would change the number, so you have to compensate by replacing that value in the powers of 10. So it's like you're multiplying the number by 1, so you're not changing its value. So these two parts convert the mantissa to the way we want, and then the other tens go into the powers of 10. And if you want to check multiplying this by 4 tens, it's easier to see here. If a decimal point starts here, if you multiply by 4 tens, 1, 2, 3, 4, you're back to the original number. And an easy way to remember what powers of 10 is just to count the number of zeros. 4 zeros, so it's 10 to the 4th. So for a very small number, again, we're just multiplying it by 1. So here, to get the decimal point to be 2.5, we have to multiply by 10 once, twice, 3 times, 4 times. So that's this part. If we multiply it by 10 4 times, we get to 2.5. But we have to replace that value by the other, or to compensate for that increase, we have to compensate it with a decrease representing the powers of 10. The 10,000 in the denominator becomes 10 to the 4th. And if we represent that in the numerator, it's 10 to the minus 4. So metric notation writes numbers with powers of tens in multiples of 3. So that's to correspond to metric names. 10 to the cube or 1,000 is a kilo. 10 to the 6 is a omega. On the small sizes, it's milli and micro. 10 to the minus 3 is milli, 10 to the minus 6 is micro. So we can either move the decimal point 3 or 6 places or 9 places. Here, 6 would be too much. So here we decrease this by dividing by 10 3 times. So we have to replace that value by 1,000, which is 10 cubed. So in metric notation, the mantissa will have 1, 2, 3 digits. So here they have 250 times 10 to the third, which is kilos. Okay, so here to get to at least one non-zero digit to the left of the decimal point, well, 3 won't be enough, so we have to go 6 places. So we're multiplying the mantissa part by 10 6 times. So we have to compensate by dividing by 10 6 times. And since we're dividing, it's 10 to the 6 in the denominator. If we put it in the numerator, it becomes 10 to the minus 6, or micros. Let's look at some examples. So write this in scientific notation with 1 digit to the left of the decimal point and powers of 10. So for the mantissa, we have to make this smaller by 3, 6, 7, 8 sizes. So the decimal point is 4.18. So since we decrease the mantissa part by 8 tens, we have to replace that value in 8 powers of 10. And we won't go into analyzing this in detail. If you want to, you can pause the screen and do it yourself. But the shortcut is if you make the decimal part smaller, you need to make the power of 10 larger, or vice versa, to keep the value the same. To write this in scientific notation, we want this to be 9.57 in the decimal part, 1 digit to the left of the decimal point. And to do that, we're going 1, 2, 3, 4, 5. So we've increased this value, the mantissa's value, by 5 tens. So we have to compensate by dividing by 10 5 times, which is 10 to the minus 5th. So to convert this to metric notation, we can move 3 6 places. So the decimal point becomes 138. And since we made this smaller by 6 sizes, the powers of 10 has to be increased by 6 sizes. And we won't go into detail in analyzing this. You can pause the screen, and if you want to look at the details. To write this in metric notation, so we need to go 3 6 sizes. So the mantissa is 58.8. Okay. And since we increase this by 10 6 times, we have to compensate by making this dividing by 10 6 times, which is represented by this. So this would be 58.8 micros. To conduct operations with scientific notation, you need to first convert the numbers to their scientific form. So in this multiplication, to get the decimal with 1 digit to the left of the decimal point, we have to divide this by 10 5 times. So we have to compensate to replace those 5 tens in the powers of 10. And here we increase this by multiplying by 3 tens to get the mantissa with 1 digit to the left of the decimal point. So we have to compensate for that by dividing by 3 tens, which this represents. And then you deal with the mantissa and the powers of 10 separately. So with the mantissa, 5 times 2.5 is 12.5. And 10 to the 5th times 10 to the minus 3 is 5 plus a negative 3, or 10 squared. But now this isn't in scientific notation. So to do that, we need to make this smaller by a factor of 10, which means we have to make the powers of 10 larger by a factor of 10. Okay, so in this case, to get the mantissa to 3, we have to, 1, 2, 3, we have to multiply it by 10 5 times. So we have to compensate by dividing by 10 5 times, which this represents 5 tens in the denominator. Here, this is 3 sizes larger, so we have to compensate it by powers of 10, 3 sizes smaller. This 2 sizes larger, so powers of 10, 2 sizes smaller. So now we deal with the mantisses separately. 4 times 3 is 12, divided by 2 is 6. And powers of 10, if they're on the same line, you add. So minus 5 plus a minus 3 is a minus 8. And remember, the rule for division is you subtract the denominator's powers. So it's the numerator's powers minus the denominator, which is a minus 2. And a minus of a minus is a plus. So minus 8 plus 2 is minus 6. If you're adding or subtracting, the powers of 10 have to be the same. So 10 cubed is 1,000, 10 squared is 100. So you can't add $2,000 bills and $300 bills and say you have 5 of anything meaningful. You have to convert these to this to 10 cubed or this to 10 squared. They have to be the same. So in this case, we're converting this to 10 cubed. So the powers of 10, it gets larger by a factor of 10. So the mantissa has to get smaller by a factor of 10. So $2,000 bills plus 3/10 of a $1,000 bill. So again, these are like units, so we can add them. We get 2.3 times 10 to the third. With metric notation, again, you have to convert each number to its metric form. So here we can only go 3 spaces. So we divide by the mantissa by 3 tens. So we have to replace that by 3 tens here. Here we make this larger by 3 tens, so we have to divide by 3 tens to compensate, which this represents. And then we multiply the mantissas, 750, powers of 10, 10 to the third plus, or 10 to the 3 plus a minus 3. 3 plus a minus 3 is 0. 10 to the 0 is 1. Anything to the 0th power is 1. So here, to get a metric form, 3 spaces isn't enough. We have to go 3 more. So that makes this 30. Since we made the mantissa larger, we have to divide by those 6 tens. So here, we go 3 sizes larger. So that becomes 3 sizes smaller in the powers of tens. 3 spaces here makes this 20. Since that part was made larger, powers of 10 goes smaller. Now we deal with the mantissas and powers of 10 separately, just like with scientific notation. 4 times 30 is 120, divided by 20 is 6. And the powers are minus 6 plus a minus 3 minus the denominator, which is minus a minus 3, which becomes a plus 3. So this gives us minus 9 plus 3, or a minus 6, which would be 6 micros. So that's the end of our review of scientific and metric notation and operations. This has been a review of scientific and metric notation and operations. You can find more details and practice in the MathGalaxy Pre-Algebra Fun tutorial. Thank you for listening.